Good afternoon. We are team number 5 with the members of
Michelle
and Javier Mejia. And we will present to you our intersemestral project that involves databases and vectors and linked lists as main data structures. Okay, so let's start with the problem background. We first envisioned that we will be using 2 different databases. One main database that is already pre-established, which contains the artists, the elements, which contain like the song, the artist, and the genre, and a custom database that the user will create by copying and adding elements from the main database. So the problem lies in creating a comprehensive database with specific user interaction features, such as copying and adding rows. In the main database, the aim is to have these 2 operations. And also, this means that other operations like deleting the elements from this database are not allowed. So the main stakeholders are individuals who engage with substantial pre-established data, who require to maintain records of information without deleting history or data, and have an effective use of memory and storage. And with the custom database, it allows for customization based on preferences, copying rows as indicated by the user. And for the stakeholders, these are mainly individuals who interact with dynamic databases, and they should be able to perform functions like inserting and deleting data in any given order.
Okay, for more clearing information, the first database that we created is for mainly the user of the developer, and the second database is mainly for use by users. So we decided to use 2 main structures, that is vectors for the main and general database, and linked list for the personalized database. The first characteristic that allowed us and made us decide for vectors is that we can access the elements in constant time. This database is like created with pre-established information and only allows the user to add info, but not very frequently. And the second is like a personalized database where the user can copy the information from the general database and paste it in the linked list and traverse around the linked list. And for example, inserting certain data at the beginning or at the end. And the main feature that made us decided for linked lists are the easy insertion and deletion of elements, mainly when they are added in the beginning is O1 time in big notation, and the efficient expansion and contraction. The vectors usually creates with a pre-established size and you can modify it, but the linked list can expand or shrink as wish.
Yeah, so the main justification for the data structures that we chose are the vectors allowed to store homogeneous data types. If you want a vector of integers, you can have a vector of only integers. Of floating point numbers, only floating point numbers. So they allow for the storage to be in the same memory block, but you have to pre-establish the size of the vector. You also, this allows to consistently access and copy information for use in other contexts, which is something that we are using constantly in this application. Regardless to structure size, the access to elements is all one time as they are in a sequence. So they also allow to access elements in an ordered fashion in a single memory block, and they allow for storage in continuous large memory chunks, which reduces the likeliness of memory leaks or segmentation Also, with linked list, they do not require a known memory size at the beginning. And this also allows for uh, basically undefined expansion. You can have an indefinite numbers of elements added. They offer constant insertion and deletion with an average of 1 time. Allocation is done individually for each element, which reduces fragmentation problems. They are like in different parts of the memory. They allow to store data of different types and sizes, which makes them very versatile. And they give the greatest capacity of data retrieval.
And last, our specific application is focused in systems like Spotify, where there is a general database where you can copy the information and paste it in your personalized database. And here the songs you put in your personal database. And for computing problems application, we manage joining data from the general database to your personal database. The data transformation, as we transform the data when you introduce it to the general database. The analysis, that is copying the information according to the type of data. The backup, the data restriction, and when you only like to include certain type of data in your database, and the constant access.
Here are the references, and now we'll present to you the algorithm. So it starts with setting a size to the main database, which is already fixed. And also then it goes to create the personal and the database. So then it adds rows, which are the vectors for the first database with vector 1, vector 2, and vector 3. And here the loop begins. So it asks for two possible inputs, to add to general database or to personalize the database. So if you select G, it goes to the general database. It's taken as a yes. And here you can add values to C1, C2, and C3, which are the 3 different columns. So it's the song, artist, and genre. From here, the database is made like one size bigger, yet the size grows. It adds the rows. It again starts. So we're going to break out of it. We type anything else, and the cycle ends. But here, if you select the other option,
And then when you select the other option, it allows you to transform or modify the database according to the user needs, and allows you to add first, add end, delete, see the list, and clear all the list. And you can see it in the code. For example, if you type like G, you can add a song.
wonderful. The artist Oasis. The genre rock.
Here it's added at the end, and it's transforming to a
New row in the database.
and when you personalize, you can add first and add at the end the number of the data. And when you see it, at the top it's the number of data. And for example, if you want to delete
Yeah, because there's no value. So.